All right, everybody, welcome to Earth Science. Here we go. Hawaiian Rainfall Lab, which is going to be a little bit of a heavy one. It's going to be a big one. We got to combine different ideas that we've done. You should have done this note sheets already. If you didn't do this, go back and do that. You don't want to jump right into this. And I also say I recommend keeping this with you as a cheat sheets that's going to pop up again and again. For example, that looks familiar, doesn't it? So I'm going to probably shoot this all as one long video, and then I'll do timestamps because I know that you're likely to like jump on and off. It might take a couple of periods, all of that. So I'll do timestamps that'll say like, "Hey, Mr. F, how do I do this thing?" And then I'll just timestamp right to it. So get comfy, jump in. We got a few minutes of work ahead of us. Beginning with vocab. Let's make it a little bigger. Which I'm gonna do like I typically do kind of non-sciencey sounding definitions. Let's keep them pretty straightforward. ISO, I believe it's ISO heat. Correct me if I'm wrong. But what this is an ISO line, which you guys have done a whole bunch of in the last week. Hopefully we got that down. But this one connects points of equal rainfall. We did generic ISO lines, you did contour lines, which are for topography. You did isotherms for temperature, you did isobars for pressure. This is all the same principles, nothing's different whatsoever. Only the numbers on the map represent rainfall. Let's do windward and leeward together. I don't know why they made them. It's funny on this lab. This is adopted from out there on the internet. This is the side of the mountain. I'll do capital facing the wind. Copy and paste works. Whereas leeward is the side of the mountain. What do you think? The back side of the wind. Now, you guys already did this note sheet. You should have done it. The windward side is where the wind is coming at the mountain. The leeward side is the back, opposite that. Orographic effect, again, in simple terms. Let's not try to confuse ourselves here. This is how mountains, quote unquote, create rain. Cave is maybe not the perfect word to use there, but I think he gets the point across. Rain shadow effect is just another term for orographic effect for that above one, or just draw an arrow. I never really have liked that term, honestly, but some people will say that the back over here, the leeward side, the dry side, is the rain shadow, like the way that light casts a shadow on something. The mountain has a shadow of rain, I guess. I don't know. I'm not nuts about it, but I don't get to make all the decisions. All right, trade winds. I'm going to pop down here real quick. This is a reference table, so you should have maybe noticed this before now, but if not, here's a reference table that has these belts of wind. We live between 30 and 60, so we live in the southwesterlies. We live where our prevailing winds, our prevailing weather comes out of the southwest, basically moves from west to east across the country. Today we're looking more in detail because Hawaii is down here at the ones between 0 and 30, and those are the trade winds. So how about we do the direction and the definition? They are northeasterly, so let's say it's the NE, northeast wind belts where Hawaii lives. All right. So there's our definitions. That's the basic premise of where we're going forward. And again, if you didn't watch that video, go back and do it. That's got the meat and potatoes of the premise. So here's job number one, which is going to be intimidating a little bit. I'm going to throw some help, but you're going to have to work a little bit. We're going to draw 500-foot contour lines, which are for elevation. And since we're in the ocean, sea level has an elevation of 0 feet. So the 0-foot contour line is kind of a freebie. It's automatically done for you because it is the shoreline. And then you're going to draw 500-foot ISO lines, contour lines. So you're going to need to grab the pencil tool. I recommend keeping the thickness pretty thin, maybe even 0.5. And like, I'm not going to do the whole thing, but I'll get you started. You got 500, 500, 500, 400 is lower, so that goes towards the ocean, towards the zero line. Oop. Some folks in class pointed out if you have a stylus available to you anywhere, that touchscreen with a stylus really, that was really handy for these. And so on. So I think I'll stop there and make you guys do some work. The 500 will come all the way around. Now, what always happens in this lab is there's a couple confusing ones. So what I think I'll do is point out some of the confusing spots, like this, all the mountain peaks, which are important in this lab because we want to look at topographically where are the high points and then compare the wind patterns to those. Um, but what can happen here? So your 500 is going to look like that. I'll go over here a little bit just to give us an example. The 1000, now people get all bent out of shape with the 1000 because there's numbers here, and it starts to get a little bit confusing. So what can happen is if there's an individual peak, like an individual prominence, it can be on its own with its own isolines. So this 1000 right here should go between 900 and 1500 because you got to go by the value 1000 there, right? And over to here, and over to here, and so on. But that leaves us with an issue here. So, if you were hiking, yes, you got up to 1600 feet here. What we would need then is two more circles to say, there's your 500. The one I'm drawing right now would be your 1000. And then around that would be a 1500. So if you're climbing, you go like up to a peak, back down. Or climbing from here, you go up to a peak, then back down, and then start coming back up over here to the 1000. It's okay to have separate bubbles. That's harder than any of the isolines I had you do in your isoline packet. But that's what we're doing here. We're making ourselves think a little bit more. Yeah. All right. You'll do the 1500. You'll do a whole bunch. So if you want a few hints, this one over here is going to have 3 circles around it, one of which is a 1500. Because you got to go 1500, 2000, 2500, and then that peak is 15 feet above that. What else? This one up here has like a ton. So the 2000 is really typically the one where people kind of like, even if you got the beginning, people kind of fall apart on this one. Now you're free at the beginning of this just to say, Mr. F, I got this. I know how to do these lines, and just work it on your own if you'd like. Oops. Or fight with me. Do it this way. So what I did, there's a couple different ways that you could like technically get this done with the data that's given. There's more than one possible correct answer, but I think it's easiest. 1500 is lower. And of course, that 1500 should be drawn in. You normally don't draw these by randomly jumping around numbers. Could you connect those two there? Yeah, people do that sometimes. I won't fight with you. Then you got to do, so think about how much it would take. If you're going to go from 1500, the 2500 is easy. You tend to save yourself some space though. Because here's where you're going to have to use your noggin. If you go from 2000 up 500 more is where there's another line to 2500, and we got to go all the way up to 4208. How many more lines are you going to need there? You're going to have to draw some in. And I'd like you to try to figure that out. Count. If you got to go from 2500, go by 500s. How many do you need before you hit 4000 would be the highest line you got there. Same thing over here. You'll have a couple. Circle that. This 1247 can actually sit in there okay. By the time you draw your 1000 line, which has to go outside that 1250. If you go to this side of the 1247, then that's legal and you don't really need anything else there. All right, so press pause. Do the split screen thing too if you know how to do that on a Chromebook. Like do Windows, and you can do control bracket to like snap them both sides of the screen. And then if you have yours and this one open at the same time, you should be able to do the rest of that. This is incomplete. Please don't hand in your lab looking like this. I gave you some pretty good hints to get you started, but the rest will be on you to draw those. All right. That's it for procedure A. That should get you there. All right. Then we'll go to procedure B. And again, I'm going to timestamp it so that if you're asking questions on this, the video should have just popped to this. Welcome to Earth Science. I'm thinking, because this always confuses people, here's what this should look like in the end. I'm thinking I would like this year, and maybe I should have just edited the lab. True. I'd like to start with step 3, because what people do is they get this all colored, and they don't realize what they're doing on this map. This map is these ISO heat things that we defined up top. These are points of equal rainfall. So this is, take a map of Hawaii. These are not where the mountains are. These are where the heavy rains are. These ISO lines connect points of equal rainfall to show us where the heaviest, rainiest spots are. So what happens typically as we're doing this lab, the mistake that gets made is that people will take these mountains when you're supposed to copy them from this map onto this map, and they'll put them right inside those circles, thinking that these are ISO lines for elevation, but they're not. Okay, so I think step 3 is the wisest one to do first. In which case, we're going to need. We even have a little triangle tool. If you can do that in black, look at that. Look at all those angles. I like it. So what we want to do is use this triangle tool to draw a mountain exactly in the same place. If you take one map and another map, it does not move mountains. These mountains exist in that spot, and they will for your whole lives until Hawaii erodes down, which will be lifetimes and lifetimes and lifetimes from now. Those mountains are going to be there. So in this exact spot on the other map, we're going to draw a little triangle for the mountain. Now that's a little bit tricky. You got to like picture where this bay is, where that little nub is, and try to just say like in your head, okay, I'm thinking it's right about there, which I know is not super easy. But what do you think? Right about there. The mistake would be if you put it right in the middle of these circles. If you put it right in the middle of these circles, you're clearly not watching this video right now, right? This looks great. This proves a point that this lab is trying to show us by combining this effect with where the mountains exist. Why don't I just do all 4 of the mountains, all 5 of the mountains to help us with this. So here's another one. Okay. I'm thinking right about there. Yeah. All right, this one. Right about there. One more is like right off the point. Right about there. Not perfect, not terrible. Right about there. All right, so there are the mountains from the previous page. If you got to press pause, if you just want to press pause and like try to copy that exactly, that's fine with me. We want those in there. Okay. I don't know if there's ways to make those like. Ooh, look at that. If you do it with like a thick pen, you just get a solid triangle. That probably would have been better. I like it. So there's our mountains. All right, that's step 3. Now let's go backwards. Again, this is a little bit time consuming, but you'll figure it out. It's meant to give us more practice with ISO lines, just kind of in terms of their function, what they look like. It's one of those things that's like easy, maybe a tiny bit time consuming, but you guys will do it. You'll do well. So normally we use a black colored pencil to darken the following lines: the 20, the 50, the 100, and the 200. How well is that going to work this year in Cami, since we don't have colored pencils? Maybe with a thickness of about 4, darken those lines. I think that, does that stand out? I mean, you could use, if you want to use a color that's not one of those colors for it, so they stand out a little bit better, I'm comfortable with that. If you want to change this, but we're going to need those colors, so I'd advise not using those. I think, should I press pause? Maybe I'll press pause and I'll do the rest so that you don't have to sit here and watch me struggle and mumble as I go through the rest. Then I'll show you what it looks like at the end. All right, one moment. Okay, we're back. I did all of that. One thing that happened that I didn't really like was with the black lines, the black mountains kind of disappeared. So I'd say then all I did was change the triangle color to brown. I made them brown. So of course brown might be one of the colors we use. Oh, of course it is. But we'll figure it out. I mean, I'm going to have you doing these in a little bit of a lighter color anyway. So you'll see. So let's do that. What we're going to do now is color. If you're greater than 200 inches, a lot of rain, we're going to color that blue. So what I think we'll do is pick a blue, put your pen on like a little bit thicker so that it's less work. This is going to be key though, this transparency thing. What this means is that like when you put your ink down, can you see through it a little bit? If you set that down pretty good over here, now when I draw, like you can still see the text behind it. That's going to be crucial. So do that. I got that all set up. Greater than 200, like 200 to 250 to 300 in here is going to be blue. So you'll just color that all blue. And I don't know how Mondo think you can make this and still be effective. What do you think? Between 100 and 200 will be green. So same effect. Looks like transparency just stays. So I got, oh, I didn't do my 100 line. Beautiful. Um, let me just update that quick. Okay, fixed. So between 100 and 200 will be green. So again, you'll get the hang of this. Make this all green. I'm not going to get too bent out of shape if it's a little bit sloppy. Kind of like that ish. I was never very good at coloring between the lines. That's not hard to imagine. There you go. A little bit more green down here. And some green up here. And you'll just keep going with that until you got a whole map that's nice and pretty looking that looks like that. I would ask that you stick with the same color scheme because it's going to make the questions and some of the things we're doing here a little bit easier. Yeah, so you'll end up with a fully colored map like that. All right. Again, I'm not going to do the whole thing. I'd like you guys to go ahead and try to finish that. I'll do one more spot of green. Bang. There we go. I'd like you guys to go ahead and finish that. And you'll do great. And that actually does it for all of procedure B. Now, we should think about what this lab is trying to show us, and that is that when these winds are coming out of the northeast and hitting the mountains, you get a lot of rain on that front side, exactly like the hill plateau. That creates a lot of snow and rain for us. We notice it more with the snow, but it works exactly the same in warm temperatures with the rain. And then on the backside, it tends to be dry. So what we're seeing in this lab, the whole point, if we have to say like right here at this moment of this video, what's the point of this lab? Besides some practicing and some things like that, the big theme is that as the wind comes at these mountains, the windward side in the wind is wet, the leeward side is dry. As the wind comes at these mountains, if you can picture that as kind of a big ridge, the windward side is wet, the leeward side over here is dry. I mean, the difference between 300 plus inches of rain a year and 15 inches of rain a year is significant. This is the thing that really happens in Hawaii. When you do this over here, this will be yellow. So this patch is pretty dry in a relative sense, in a Hawaiian sense, compared to this patch, because the winds are coming at us out of the northeast like that, rising up, giving us a windward wet, leeward dry. Okay? Excellent. All right, so here's what we're going to do for procedure C. Is really like that's what all the stuff I just said about what is the point of this lab. Look at the latitudes map from map A, color the region that is found. So Hawaii, as I mentioned at the beginning, is found in this wind belt. We're going to color that. I don't care what color, just whatever you have selected. Chuck it in there real quick. Boom. That's where Hawaii lives. That's step one. Step two, the trade winds in this area, prevailing winds, which direction are they coming from? There's reference tables right there. Tells us they're coming from the northeast. Go to the map you colored in procedure B. Draw 3 or 4 large arrows on the right side of the map to indicate the prevailing winds. This is classically skipped when people are doing this lab with pencil and paper. So let's make sure we do it. I'm going to draw arrows just like they are in this reference table. I'm going to do it with a pen color that works. Oh, all right, we'll do it red. I don't want to do it red. Short story long. Hawaii lives in a wind belt where these are the prevailing winds coming out of the northeast, just like it says right there. So that takes care of procedure B. Or number 3. There's nothing right there. Describe which side of the mountain using compass directions are wet and dry. So if you know your compass, you don't have to write this over there if you don't want to. North, south, west, east. This side of the mountain is wet because it's in the prevailing winds. It's getting hammered by the wind, and therefore, with the orographic effect that creates rain. And then this side of the mountain tends to be a little bit more dry. Okay, so the next one, which isn't there, this happened on the isoline packet too. There it is. If that is missing for some reason, this is like a weird glitch in Cami where it'll be there, it won't be there depending on your zoom. So play with this a little bit. If below that is blank, that's a problem. All right. What you're going to do, and I'm going to leave you to it, is basically do all this again. Which I know you're probably saying, I quit, but we got a couple days. Don't panic. I know this is a lot of work, but you're smart folks. You'll figure this out. This is another Hawaiian island. Hawaiian is like a little islands, right? So here's another one of them. So everything should work exactly the same. So can you basically do that again? You're going to darken those lines just like you did in procedure B. You're going to draw the wind directions just like we did in procedure C. I'll do that for you. The wind directions are the same. It's in the same prevailing wind belt. It's in the trade winds, those northeasterly breezes. All right, there's number 2. Use your brain and tell me where the mountains would be. Where would the mountains be if all of this is true, if all these patterns are the same on one island and another? Once you draw these for the rainfall, this is another rainfall map. Where must the mountain peaks be if they're getting a wet side in the front and a dry side in the back? 2 of them, right? Yes, 2 mountain symbols. So use the little triangle symbol, throw them in there in the right spots. You can do it. All right, questions? That, look at the reference table up above between what parallels of latitude. You already did it. That one and that one. That's where Hawaii lives. Which coastline? You already did that, so you can tell me compass direction. You can figure that right out. You can figure that right out. That we've already said multiple times. These questions are slightly repetitive, huh? All right, I'll tell you what, skip this one because you're going to do it down here. This is going to be like another infographic idea. Hint, hint, you have a cheat sheet that has all of this on it already. So just go to that and tell me why one side of the mountain in Hawaii gets wet while the other side gets dry. People always ask if they have to do it from one side or the other. It doesn't really matter. If you show, because if you were in a boat looking at the island of Hawaii on one side, then you sail around the other side and looked at it, then your right and left would be messed up, right? I don't care how you draw it. As long as you say the winds are coming from this direction, here's all the stuff that happens. If you don't want to complicate your life, just do it exactly the same as we did on that sheet, and you'll be fine. Regions question, because this happens. This was a regions question about the Tug Hill Plateau and Pulaski, right? So this would be like Lake Ontario, Alaska would be kind of like right at that dot, maybe a tiny bit more inland. Tokyo Plateau, Adirondack. So here's a reading on lake effect snow. Some questions on that. Yep, very doable. And then you're going to create a detailed infographic to show, hey, if you're new to Pulaski, here is what happens in the winter, which is why we get so much snow up there. That reading can help. What do you think? If we fought through all that, then you have successfully made it through the Hawaiian Rainfall Lab. Excellent job. And we'll move on from there. So how long do we take on that? The whole 25 minutes. She's a doozy. But spread it out over a couple periods. You guys will, I suppose you're done at this point. All I have to say is good job. Good job, folks. We'll talk to you soon.